Beneath Yellowstone's geysers and bison, a giant force of nature slumbers, a supervolcano. This vast chamber of magma powers the park's famous geothermal wonders, from Old Faithful to the Grand Prismatic Spring. But this giant has a violent past, written in layers of ancient ash spread across the continent. The Yellowstone caldera, a massive crater, is so large you could fit Tokyo inside it. It formed not by a mountain exploding but by the ground collapsing into an emptied magma chamber. This is geology on a scale that humbles us, forcing us to think in terms of deep time and planetary forces. The question isn't if this giant will stir again, but when. Yellowstone has erupted 3 times in the last 2.1 million years, each event reshaping landscapes and altering climates. The last super eruption, 640,000 years ago, was 1,000 times more powerful than Mount St. Helens in 1980. It ejected enough ash to bury Texas 5 feet deep. The park's beauty masks a potential for violence that commands respect and scientific curiosity. So we watch and listen, placing instruments on the ground to hear the heartbeat of the sleeping giant. We measure the ground as it breathes, rising and falling with the magma's pressure. We analyze gases seeping from the earth, searching for clues of change. For decades, we thought we understood its restless slumber. But science is a journey of discovery, and recently, we realized we'd been missing most of the conversation. The giant, it turns out, has been whispering secrets we were never equipped to hear. Until now. For years, listening to Yellowstone was like hearing every 10th word in a crowded room. Our seismometers picked up only the obvious earthquakes, missing the subtle language hidden in the noise. Enter a new kind of explorer, the algorithm. Scientists turned to machine learning, training an AI to find patterns in over a decade of seismic data. The AI learned to spot tiny, almost imperceptible earthquakes buried in the static. The result was astonishing. The official catalog listed about 10,000 earthquakes for a given period. The AI found those and tens of thousands more. In total, it identified over 86,000 previously unknown hidden earthquakes. The earth beneath Yellowstone wasn't just rumbling, it was chattering constantly and complexly. This discovery fundamentally changed our understanding of the volcano's plumbing system. We went from observing isolated events to witnessing a continuous, intricate dance of tectonic stress and fluid movement. These weren't random tremors. They were part of a larger, interconnected system deep within the crust. The AI didn't just give us more data, it gave us a high-resolution map of the forces at play. The sleeping giant is far more restless than we ever knew, its dreams filled with a constant tremor we're only now beginning to comprehend. Yellowstone's whispers have become a symphony. What are these thousands of tiny earthquakes telling us? Many occur in clusters, earthquake swarms. Unlike a main shock-aftershock sequence, a swarm is a rolling drumbeat of tremors, lasting days or even months. In volcanic regions like Yellowstone, swarms are the volcano's primary way of communicating its internal state. They're often driven by the movement of fluids, magma, superheated water, and gases, forcing their way through cracks in the crust. As these fluids move, they create stress, fracturing rock and generating cascades of small earthquakes. Think of it as the Earth's plumbing groaning under pressure. Each swarm is a clue to the dynamic processes happening miles beneath the surface. Discovering 86,000 hidden earthquakes isn't just about numbers, it's about patterns. These tremors fill in gaps, making swarms appear more extensive and longer lasting, and revealing new swarms we never knew existed. It's like upgrading from a blurry photo to high-definition video. We can now trace the pathways of underground fluids and better understand the intricate mechanics of the Yellowstone supervolcano. The Earth's hidden symphony is finally coming into focus. The real power of this new earthquake data is in its precision. Each tiny quake acts like a flashbulb, illuminating the darkness deep underground. By mapping these tremors, scientists have traced a network of previously unknown fault lines beneath Yellowstone. Many of these faults lie directly under the park's most active geothermal areas, like Norris Geyser Basin. This discovery provides a direct link between the deep volcanic system and the surface features we see. The swarms are happening along the very conduits that channel heat and water to the geysers. These faults act as valves, controlling the flow of fluids from the depths. When pressure builds, fluids are forced along these faults, triggering swarms and feeding the hydrothermal systems above. This detailed map helps explain why certain geyser basins are more active and volatile. Yellowstone's inner workings are more complex and more connected than we ever imagined. So, what does all this hidden seismic chatter mean? Is the sleeping giant waking up? The consensus among scientists is reassuring. No, Yellowstone is not about to erupt. Earthquake swarms are normal for a healthy, active caldera like Yellowstone. The machine learning discovery doesn't reveal new danger, but the true extent of normal background activity. We're simply hearing the volcano's baseline hum with greater clarity. This new detailed baseline allows scientists to spot any deviations from the norm. Before an eruption, we'd expect dramatic changes, intensifying swarms, rapid ground deformation, and shifts in gas chemistry. The discovery is less a warning and more a Rosetta Stone, helping us translate the volcano's complex language. The probability of a super eruption remains incredibly low, about 1 in 730,000 per year. These findings empower us with knowledge, replacing fear with understanding. The giant is whispering, not shouting. While an eruption isn't imminent, it will happen someday. A Yellowstone super eruption would be catastrophic, an event of planetary scale. The ground would rip open, unleashing a pyroclastic flow that incinerates everything within 100 miles. The immediate area would become a wasteland, with no chance of evacuation once the eruption began. A colossal ash plume would blanket much of the U.S., collapsing roofs, contaminating water, and halting machinery. Air travel would cease, and the ash cloud would block sunlight, triggering a volcanic winter. Global temperatures could drop for years, devastating agriculture and leading to famine. Sulfur dioxide would create acid rain, poisoning lakes and soil. A Yellowstone eruption would challenge the very foundations of civilization. It's a scenario we study not out of fear, but to prepare for the unimaginable. Can we prevent a super eruption? NASA once considered a bold idea: cool the volcano down. The plan involved drilling deep wells to circulate water, bleeding heat from the magma chamber over centuries. The steam could even generate clean electricity. But the risks and costs are enormous. Hundreds of billions of dollars, and the danger of triggering an eruption by accident. The technology is unproven, and most volcanologists agree our resources are better spent on monitoring and preparedness. Understanding the volcano and forecasting its behavior is more realistic than trying to defuse a geological time bomb. The NASA plan remains a fascinating what-if, a testament to human ambition, and a reminder of nature's power. For now, our best defense is vigilance, not intervention. Yellowstone's fate is a cosmic challenge we're not yet ready to meet. While we can't stop an eruption, we can watch for it. The Yellowstone Volcano Observatory is our early warning system, monitoring the volcano's every twitch and sigh. A dense web of seismometers, GPS stations, and satellites tracks earthquakes and ground deformation in real time. Scientists also monitor water and gas emissions from geysers, looking for chemical or temperature changes. Infrared imagery and airborne surveys help spot new hotspots. All this data flows to monitoring stations where scientists look for patterns and connections. The discovery of hidden earthquakes adds a powerful new layer to this data set. By understanding Yellowstone's normal activity in detail, we're better equipped to recognize the abnormal. Our vigilance gives us precious time to prepare if the giant ever truly awakens. The revelation of 86,000 hidden earthquakes is more than a statistic. It's a leap in our ability to listen to the Earth. Machine learning has opened a new window into the life of one of our planet's most formidable volcanoes. This deeper understanding helps us replace fear with preparedness. The same techniques can be used worldwide, improving hazard assessments and forecasting for other volcanoes. Yellowstone's story is about our place on a dynamic, powerful planet. Science is our candle in the darkness, letting us see with ever-increasing clarity. The discovery of these hidden tremors is not an endpoint, but a new beginning, an invitation to listen more closely. By monitoring the sleeping giant, we protect ourselves and deepen our connection to the magnificent planet.